When you think about calculus, you think of it as some far-fetched idea that is incredibly hard to understand. One of those far-fetched topics in calculus that you may find in particular incredibly difficult to understand is derivatives, which are represented as d over dx as this operator, or dy over dx like in context of a function. However, the concept itself is actually not that hard to grasp. In fact, I could use Roblox to explain how they work. Hop into a game with me and check this out. I'm going to use Restaurant Tycoon 3 for this example because it's simply a tycoon game and it's easier to use for this. And also have the best stats in here. So let's use this. This is basically a game where you have to serve people and you have staff, chefs, and things like that gets people at these like tables. These people get like 3-course meals and stuff like that. And like most tycoons, oh my god. Like most tycoons, your goal is basically just to make the most amount of money as possible, to make the best restaurant you can, and also to get the highest rating, which I clearly do not have. But the goal is money. It's all just money in the end, right? And you do that here by sitting these customers down. You give them what they want. You just hang the ropes out here. Pretty simple, right? Well, you could use kind of calculus for this. Think about it. When I first joined this game, I start off with $28,000 because I'm that rich. Well, in about 4 hours, I would say that would go up to around 40 grand. For context, I'm just going to round up 28K just to 30 so that the calculations are more simpler. But you have this money here and you have in 30K. You're beginning with 30K right now. And then 4 hours from now, you end up getting 40K. Simple. Here's where it gets pretty interesting. There's something called a rate, which is basically how much something changes within a certain amount of time. Rates are expressed in things such as meters per second, feet per second, or also just anything, how things change and how things move. Well, think about this too. Money is also a rate here. You're getting a certain amount of money within an hour. So I know that I started off with $30,000 when I first joined. So this is hour 0. And then I got up to 40K after like 4 hours. So this would be hour 4. To calculate rates, all you're really doing is just finding out how much something changes. To calculate a rate, it's really simple. You just find out how much something changes over the time. In this context, to make it more official and into its actual formula, it would be y2. This represents your function or anything that you have, the output of your function, and then their respective inputs. This just shows how much the function has changed in value, and this shows how far apart like your inputs are. This is basically just saying, oh, how much has my money changed? And how long has it been? This is going to be very important to use later on, so please remember this. If that's kind of hard to remember, just remember this formula. So to calculate my rate of my money per hour, what I will do, I'll do 40 minus 30. I ended up with 40K when I ended, and I started off with 30. And then around 4 hours pass, which is just 4 minus 0. This is equal to 10 over 4, and that in itself is equal to 2.5. This means I make $2,500 per hour. This is my rate. This just means I gain $2,500 on average every hour I play the game. This in itself is already calculus. Derivatives in calculus just expresses rates of change. And these two are closely related to each other because derivatives measure specific rates of changes at specific points. They measure how something changes, how something moves. There's many ways you could use derivatives, like in motion, but you can also use it for change of things like money. And that's how I'm going to explain it here. Derivatives, their core concept is just change. How things change, rates. They are basically just rates, but really specific rates. What do I mean by really specific rates? Well, okay. I'll use a function to describe our restaurant situation better. We know that I have money at specific times, right? So let's just use a function to describe this. F of t is equal to t squared. T is the amount of hours after I join the game. And f of t just represents basically how much money I've gained in total ever since I joined. When I first joined the game, this is going to obviously be 0. But as time goes on, I'll gain more money. Okay, let's say at around 2 hours, it is rush time and you're going to get the most amount of people. So you want to find out the rate of the money you're going to experience. How much will your money start to change at 2 hours? You will want to do this because of spending reasons. Maybe you're going to find out how to upgrade your furniture during then, or I guess hire new staff, and your rate of change of money could help you make that prediction, as it can show how much your money is going to grow and it can predict how it's going to flow after rush hour. You want to calculate that rate. Let's use a slope formula. The amount of money I have after 2 hours is just 2 squared. This is going to be $4,000 I'll gain in total. Now let's use a point that's like 2 hours away. So 4 hours. 4 squared is equal to 16. Pretty simple. Now, if I want to calculate its rate of change, 16 minus 4 over 4 minus 2. Remember the formula? That is basically what I'm just doing here. This is equal to 12. 16 minus 4 is 12 over 2, which is equal to 6. That means from rush hour, I'm going to be making $6,000 per hour. I want a more accurate measurement. If I want to find out exactly how much my rate of money is going to change, if I want to find out how my money will actually change at specifically 2 hours, and I want the closest and the best estimate, this estimate is not good enough because we need to get closer to the point in order to have a rate that is more accurate. So let's just use another point. Let's use 3 hours. That's just 3 squared, which is equal to 9. Okay, now let's plug in our change. That's just going to be 9 minus 4 over the amount of time that's passed, 3 minus 2. This is just going to be equal to, this is 5 over 1. It's equal to 5 grand. Okay, notice how, like I said before, when we're getting more and more closer towards 2 hours, our rate of change is becoming more and more accurate and predictive of how our money will change. Remember how I said our goal is to get as close as possible to 2 hours when calculating our rate of change with this formula? Let's put this arbitrarily with like variables. No worries, it won't be that scary. So, when we were using this formula, we were calculating the change some distance away from 2 hours, or some hour away from 2 hours. We could represent this as f of 2 plus h. That was basically what we were doing, because 3 hours, that's 1 hour away, so 2 plus 1, 3, 3 squared, that's going to be 9. And then we subtracted our value of 2 hours, how much money we would have on 2 hours, to see how much our money would have changed. Then we divided it by how much time has passed. And we already know the amount of time that has passed is h. Okay, what we were doing before, we're just plugging in points h was 1 here because we were at 3 hours. 2 plus 1 is equal to 3. So this h has to be 0 and almost 0. It can't be exactly 0 because then this wouldn't work out in the denominator. So we want to use something that's called a limit statement to evaluate what this would approximately equal to, or at least get a general and a very good sense of what this would have to be. So h would approach 0. This is our basically class book definition or form of a derivative when you break it down to its bare minimum. Remember f of t is just equal to t squared, right? So let's just plug this into our function. The limit as h approaches 0 of f of 2 plus h minus f of 2. This is just going to become, if we plug it into our function, 2 plus h squared minus 2 squared, which is 4, all over h. Okay, now, what does this get you? How do we solve this limit? Because if we were to just plug in h as 0 directly, our denominator would just become 0, and then we would have a form that we cannot solve. Let's expand out this factor here. 2 plus h squared. 2 plus h squared, that's 4 plus 2h plus 2h plus h squared minus 4. Okay, over h. So let's solve this here. 4 minus 4, those two cancel out. We're left with our limit. 4h plus h squared over h. Okay, now check this out. We have a common term here. So we could just factor out the h from the numerator. This will be equal to h times 4 plus h over h. And check this out. We could just cancel these two out. And now we can plug in h as 0 and we'll get 4. So our limit will equal to 4. This basically just means our very accurate rate of change at 2 hours is going to be $4,000 per hour. That means if we keep up rush hour, we are going to gain this much money per hour. This is the best estimate you could get. Now, the reason why derivatives are super important is because they are super useful in predicting things. Let's say here, you're in your restaurant, right? You could use this rate to kind of, I guess, manage what you buy during rush hour. $4,000 in the context of Restaurant Tycoon 3 is not that much for most people. So if you know that you're getting $4,000 per hour and you know that that's not really a great amount of money, you could use this to predict and I guess estimate what furniture you could buy on the lower end, how many workers you could buy, and you could do that on the lower end too. And you could do so much with this in terms of planning out and budgeting just with this. That's why derivatives are so useful. And that's how you could explain them in Roblox. And next video, I'll be doing some example problems and doing some problems with you guys to try out.